Bismillahirrahmanirrahim. Assalamu alaikum students. This is Tariq, lecturer in economics. In the last lecture we were learning how to analyze, summarize, present and interpret the large data using descriptive statistical tools, tables and graphs. How we can make the data easy to read, easy to understand using tables and graphs. How we can make the data meaningful using descriptive statistical tools, tables and graph. And we were discussing bar graph for the frequency distribution to analyze, to summarize, to present and to interpret the large data by bar graph. In this section we are still graphing the bar chart or the bar graph, but for the percent frequency distribution. And it means this graph will tell us the amount of sale of each class, each soft drink in percentages. Bar graph for the 5 soft drinks, 15 purchases, percent frequency distribution. The same frequency distribution data table we have, but only category change. This bar graph will analyze, summarize the percent frequency distribution. Again, in the bar graph we have classes on the horizontal axis: Pepsi, Coke, Dew, Sprite and 7-Up, and we have frequencies, percent frequencies on the vertical axis. I am taking you back to the frequency distribution table. This is the frequency distribution table. The same classes, same frequencies, same relative frequencies and same percent frequency distribution. In this section the bar graph will summarize these statistics as a bar chart, as a bar graph, to summarize the data, to interpret the data in the using statistical tool bar graph. I am taking you back to the bar chart. This is our bar chart. From this chart one can easily read, one can easily understand that which particular class is the most attractive soft drink and which particular class is the less attractive soft drink. So the purple bar, which is the largest lengthy bar extended to the 40% sale, this represent that Pepsi is the most attractive soft drink. It captured 40% shares of the market. 7-Up represent the second attractive soft drink, which is extended to the 20% sale. It means 7-Up captured 20% shares of the market, and the other three like Coke, like Dew and Sprite, each one individually captured 13.3 shares of the market. So from this graph, from this bar chart, one can easily understand that which class, which soft drink is most attractive and which soft drink is less attractive. So Pepsi is the most attractive soft drink and Coke, Dew and Sprite are the less attractive soft drinks. As this is very clear from the interpretation, purple bar represent 40% sale, which is the major portion of the market captured by Pepsi. 7-Up captured 20% market shares and Coke, Dew and Sprite individually captured 13.3% shares of the market. So we are learning that how to analyze, summarize, interpret and present the data in an easy way using bar graph. So from this graph, from this bar chart, statistician or one can easily read, can easily understand that which soft drink is the most attractive and which soft drink is the less attractive. Now I am taking you to another chart, pie chart. We can summarize, we can analyze, we can interpret qualitative data using pie chart as well. So pie chart is another statistical tool that one can use to analyze, to summarize, to interpret, to present, to make the data easy to read, easy to understand and to make the data meaningful. How we can graph the pie chart? Statistician will draw the circle and then statistician will divide this circle into groups, into classes. How statistician can divide into classes? By multiplying. the relative frequency of the particular class with the 360 degrees to compute the degrees of the particular class, as this is given. The relative frequency of the class multiplied by 360 degrees, this is the sign of multiplication, is equal to the corresponding class degrees. I am putting few examples to develop the degrees for the particular classes. So degrees of the first class Pepsi, relative frequency of the Pepsi 0.40 multiplied by 360 degree is equal to 144 degrees. So we multiply the relative frequency of the class Pepsi with the 360 degrees and we calculate the degrees for the first class Pepsi 144 degrees. Degrees of the second class Coke 0.1333 multiplied by 360 degrees is equal to 48 degrees, where 0.1333 is the relative frequency of the class. Again, degrees of the third class Dew, relative frequency of the class Dew 0.1333 multiplied by 360 degrees is equal to 48 degrees. Degrees of the fourth class Sprite 0.1333 multiplied by 360 degrees is equal to 48 degrees. Degrees of the fifth sector 7-Up, relative frequency of the class 7-Up 0.2 multiplied by the 360 degrees is equal to 72 degrees. So simply statistician can compute the degrees of the particular class, particular sector by multiplying the relative frequency of the class with the 360 degrees, and these are all the relative frequencies of the 5 classes. You can collect from the frequency distribution table. I am taking you back to the frequency distribution table. This is the frequency distribution table. Same example, same raw data, 15 purchases, 5 soft drinks. Relative frequencies of each class 0.4, 0.133, 0.133, 0.133, 0.2. These are the relative frequencies of all 5 classes. We can collect from here and we can compute the degrees of the particular classes. So I am taking you back to the graph. This is the pie chart. In here, as this is very clear, pie chart for the 5 soft drinks, 15 purchases, degrees of each sector. 144 degree of the Pepsi, which represent the major portion of the market, capture 40% sale. 72 degrees of the second attractive soft drink, that is 7-Up, and 48 degrees each the remaining 3 soft drinks like Dew, like Coke, like Sprite. So using these degrees we can interpret, we can understand from this graph that which soft drink is most attractive and which soft drink is less attractive. Now we are going toward the pie chart to summarize, to analyze the percent frequency distribution of the same frequency distribution table. We can summarize, we can interpret the qualitative data using pie chart as well. So as this is clear from this pie chart that 40% of the sale is of Pepsi, 20% of 7-Up, and Coke, Dew and Sprite sell out 13% each. So Pepsi capture the major portion of the market. This is the most popular soft drink. So this chart clarify, summarize the frequency distribution table easily. One can easily read, one can easily understand, one can easily interpret from this pie chart that major portion captured by Pepsi, which is 40% sale. Red portion define the second attractive soft drink, which captured 20% shares, and the other 3 sectors individually captured 13%. These are the less attractive soft drinks. So it's mean from this pie chart, statistician can easily interpret, can easily summarize that which soft drink is most attractive and which soft drink is less attractive. Now we are proceeding toward the next section, quantitative data analysis. In this section, we will analyze quantitative data, quantitative informations. Quantitative data, when we collect informations about any particular element of interest in numbers form. in numerical values form. So we call this is quantitative data or quantitative informations. Now frequency distribution, the same definition of the frequency distribution, the number of times of a particular data item in a particular class, that is called frequency of that particular class. To develop frequency distribution table, statistician will use few steps. In the very first step, statistician has to define the number of classes for the entire data set. It means statistician will divide the entire data set into number of classes. Statistician can divide the data into minimum 5 classes and maximum 20 classes, depends on the size of the data set. If the size of the data set is small, statistician will use small number of classes. But if the data size is large, statistician can use maximum number of classes. So in the very first step, statistician will divide the entire data set into number of classes. As I told you that minimum possible classes are 5 and maximum possible classes are 20. The second step, class width. Class width define the number of data items in a particular class. That how many data items a statistician can include into a particular class. How we can determine, how we can define the number of data items. How statistician can specify a range for the number of data items. We have this formula to define class width. Largest number of the data set minus smallest number of the data set divided by the total number of classes. Statistician will subtract smallest value of the data set from the largest value of the data set, and then the difference will be divided by the number of classes. So statistician will define the class width, and I'm again repeating, class width will specify the range of the number of data items in a particular class. And class limits. The class limit, statistician will define the lower limit of the class and the upper limit of the class. One data item at a time will appear in one class only. Statistician cannot repeat one data item in more than one classes. So we will define the lower limit and upper limit of each class, that a particular data item appear only in a particular class to avoid the repetition of one data item in more than one classes. Why statistician define the class limits? To make sure that each data item is happening one time only in one class, to avoid the repetition of one data item in more than one classes. We cannot put one data item at a time in more than one classes. That is why statistician will define the lower limit of the class and the upper limit of the class. Now we are taking one example to repeat all these terminologies like frequency distribution, number of classes, class width, formula to define the class width and class limits. We will repeat all these terminologies practically by taking one example to develop the frequency distribution table for the 20 clients annual audit. We have the 20 universities and the consultant is conducting their audit, and the audit time is given in days. This is example, develop the frequency distribution table for the annual audit of the 20 universities where audit time is given in days. As this is given, 12 days, 13 days, 15 days, 16 days, 15 days, 15 days, 20 days, 21 days, 16 days, 15 days, 23 days, 25 days, and so on. This is raw massive data. We cannot say anything about these information. Statistician cannot understand this data. Statistician cannot interpret this data. This is raw data. And these informations are just audit time, not times, audit time in days. Now we are switching toward the next section to be continued. It's mean statistician is going to develop the frequency distribution table. So as we learned in the previous slide, that statistician has to pass from the few steps. The very first step to define the number of classes. So for this raw data, as this is given again here, we repeat audit time in days. For this raw data, statistician is going to divide this data set into 5 classes. Yani statistician define the 5 number of classes. How statistician can develop the class width, specify the range of particular data items in a particular class. The formulation as we studied in the previous slide, largest value of the data set minus smallest value of the data set divided by the number of classes. So 31 is the largest value of this data set, and minus 12 is the smallest value of this data set. 31 minus 12 divided by the number of classes. Defined number of classes are 5. So 31 minus 12 is equal to 19. 19 divided by 5, we compute the class width 3.8. What does this mean? This parameter tells us that statistician can include 3.8 data items to each class. Class width will remain same. Number of data items in each class will remain same. But I put one note in here. Statistician can take the round number to make the calculation easy. Like calculated class width is 3.8, but one can use 4 class width as well for making the things easy. This note means that calculated class width, if this is in decimal, so statistician has the power to take the round number to make the calculation easy, to keep the things easy to handle, easy to understand. So we are developing now the frequency distribution. I am repeating again this note that calculated class width is a 3.8, but this is difficult to manage. So that is why statistician can take the round number, 3 data items in a particular class or 4 data items in a particular class. Suppose in this data set to develop the frequency distribution table, statistician is including 4 data items in each particular class. So class width is 4. Class width that we will use is 4. We are developing the 5 number of classes here. The first class, that is 12 to 15. Lower limit of the class is 12 and upper limit of the class is 15. Now how we can develop frequency of the first class? So we will go to the raw data set and we will count all those numbers which are greater than or equal to 12 and less than or equal to 15 in values, and we will include those data items, we will count those data items and we will include as a frequency of the first class. So let's check in this large data set: 12, 13, 15, 15, 15, 15, 12, 13, 14. These are the 9 data items which are greater than or equal to 12 and less than or equal to 15. So we count them. These are 9 and we write this as a frequency of the first class. So to develop frequency of the class, we will count all those data items which are greater than or equal to 12 and less than or equal to 15. So these data items are 9. Now frequency of the second class, that is 4. Again we will go to the raw data set and we will count all those data items which are greater than or equal to 16 in value and less than or equal to 19 in value. We will count those data items and consider as a frequency of the second class. So we are coming here 16, 16, 16 and 17. It means in the raw data set we have 4 data items which are greater than or equal to 16 and less than or equal to 19. All those data items of the data set which are greater than or equal to 16 and less than or equal to 19 we will put as a frequency of the second class. Now frequency of the third class: 20 to 23. Lower limit is 20, upper limit is 23. Again, we will count all those data items from the entire data set which are greater than or equal to 20 and less than or equal to 23, and we will include this as a frequency. We will count them and write as a frequency of the third class. So we are coming here, frequency of the class is 3, so we are counting. We have the elements 21, 20, 21, and the next one, that is 23. These three data items belong to the third class, which are greater than or equal to 20 and less than or equal to 23 in value. So we write frequency of the third class, that is 3. Now frequency of the fourth class, lower limit 24, upper limit 27, frequency is 2. It means we will count from the raw data set all those data items which are greater than or equal to 24 and less than or equal to 27, and we will count them and we will put them as a frequency of the fourth class, which is 2. So we have two data items, 25 and 25. These two data items, 25 and 25, two data items. So frequency of the fourth class is a 2, and frequency of the fifth class, including all those data items which are greater than or equal to 28 and less than or equal to 31. So we have again two data items, 28 and 31. These two data items, 31 and 28. So frequency of the fifth class is again 2. So this is the way to develop frequencies for each class. Again, we are switching toward the relative frequency distribution. So relative frequency distribution we have studied in the previous slide. I am again defining relative frequency distribution. Define the fraction, the proportion of the particular class relative to the entire data set, relative to the all other classes. How we can compute relative frequency of the class? Frequency of the class divided by the total number of observations. Suppose we are computing relative frequency of the first class. So frequency of the class is 9, total observation, total data items are 20, 9 divided by 20 is equal to 0.45. 0.45 is the relative frequency of the first class. I am again repeating, relative frequency define the fraction, the proportion of a particular class relative to all other classes, relative to the entire data set. Relative frequency of the second class, so frequency of the class 4 divided by 20 is equal to 0.20. This is the relative frequency of the second class. Relative frequency of the third class, how we can compute? We will divide frequency of the class 3 by the total number of observations. So 3 over 20 is equal to 0.15. Again, frequency of the fourth class is 2. 2 divided by the total number of observations 20, so 2 over 20 is equal to 0.1. In this way we can compute relative frequency distribution for the particular class. Again, percent frequency distribution. In the percent frequency distribution we will compute only the percentage of the particular class relative to the all other classes. So we will multiply simply the 0.45 relative frequency of the class with 100 and we compute 45%. Again, percent frequency of the second class, so relative frequency of the second class, which is 0.2 from here, 0.2 multiplied by 100 and 20%. Relative frequency of the third class, 0.15 is the relative frequency multiplied by 100 is equal to 15%. Percent frequency of the fourth class, we will multiply relative frequency of the fourth class, 0.10 multiplied by 100, that is 10%. In this way we can compute percent frequency distribution, and I am again repeating that percent frequency distribution tells us the percentage of the particular class relative to the all classes, relative to the entire data set. So this is all about to develop the frequency distribution table. If we have the raw data, added time in days, we develop the 5 classes, we develop frequency distribution, relative frequency distribution and percent frequency distribution. Now we are switching toward the let me elaborate further that what is the interpretation and what are the achievements, what we learn when we develop the frequency distribution table. So this is added time and days table, raw data, large data set which is non-interpretable, from which we cannot understand anything about which we cannot say anything, but when we develop this frequency distribution table, now this frequency distribution table can summarize, can interpret, can analyze, can present, can this data easy to read, easy to understand, and can make this data meaningful. So this frequency distribution table will make the data meaningful. We can summarize this data using this developed frequency distribution table. And I'm coming to the interpretation of the frequency distribution. So in the frequency distribution, we have different frequencies of the different classes. 9 is the frequency of first class. How we can interpret what is the meaning of this 9? This 9 means 9 universities consume 12 to 15 days to complete their audit. The 4 frequency interpretation is this, that the 4 clients audit will consume 16 to 19 days, and the 3 frequency interpretation is this, that audit company will consume 20 to 23 days to complete the audit of 3 universities or 3 clients. Similarly, 2 frequency means that the 2 universities audit will consume 24 to 27 days, and the last 2 frequency means that the 2 universities, the 2 clients audit will consume 28 to 31 days. So it means frequency distribution table tell us that what is the meaning of this raw data. I'm again repeating, 9 universities consume 12 to 15 days to complete their audit. 4 universities will take 16 to 19 days for conducting their audit, and so on. Before the frequency distribution table, we cannot understand, we cannot interpret the raw data. Now we are interpreting the relative frequency distribution and percent frequency distribution. So from this column, 3rd and 4th relative frequencies are also clear, and percent frequencies are also clear. So interpretation is this: first class relative frequency and percent frequency mean 0.45 or 45% of the audit will consume 12 to 15 days. 0.2 or 20% audit will consume 16 to 19 days. This is the interpretation of the relative frequency and percent frequency of the second class. Now interpretation of the third class: 0.15 or 15% of the audit will take 20 to 23 days. 0.1 or 10% of the audit will consume 24 to 27 days. It's mean using these statistics, using this frequency distribution table, we can summarize, we can analyze, we can interpret, we can make the data easy to read, easy to understand, we can make the data meaningful, and statistician can understand, can summarize, and can interpret now this raw data using this frequency distribution data table.